The heading for this week is resolution of forces. You need to write this down now. Resolution of forces. So in your notes, this resolution of forces, just as okay, so just as one force replaces the two forces, we can have two forces can replace a single force. And that's assuming they add as vectors to make the single force. Okay, a bit of terminology then. Okay, a bit of terminology. We resolve is the word resolve. We resolve a force into its components. Right, time for an example. We got this down here? Example. There is a single force, F. A single force, F. Imagine that single force is acting on, say, a block of steel. If the steel is going to move, which way is it going to move? In the same direction as the force, right? So block of steel here, and the force acts and it starts moving it faster that way. So what we can do is we can actually say, right, instead of having that force, I'm going to have two forces that do the same job, same effect. So I'm going to redraw it because in your notes it'll look better. I'll get rid of this bottom bit here. So I can say F So F has the same effect as two forces that add to give F. So I want you to draw any two forces. I'll give you a starting point. So that force there, I'm going to repeat it down here. It goes here, you just draw that in as you hit it. Why do I put a little doohickey underneath the F? To show it's a vector. Yeah, that's correct. So any two forces that add to give that will be the components of F. So can anybody give me some directions to what I could do? What could be the components? How would I do? You want me to do that? We'll just ignore the beast. And then I go up through my ink, with my paint, through my stuff here. So. Let's go right. Okay. I could go like that. That could be one of them. I'll call this F. What's a good name for it? F1. Yes. And I have to have two forces. So where would the next one go? Yes, right. From the end of that first one to the. So what do you call F1 and F2? Component, that's right, component forces, yep. F1 and F2 are components of F. Do you know how often we use components like that? Hardly ever. What we really, really want, almost always, I'll just give you a chance to get that down. Okay, almost always, meaning that there's the odd occasion you don't use this, but almost always you want the two components to be in two particular directions. Can anybody have a guess at what they might be? What's a nice convenient directions we could use? Yep, east and south, east and south, east at 90 degrees to each other. That's perfect, yeah. And on a graph paper, we'd call that what? Up and down and to the left and down, or left and up, whatever. Sorry? Vertical, yep, horizontal and vertical. So all those are the same. Or X and Y, okay, X and Y, but they're all correct answers. Almost always, we want components. Almost always we want components in the X and Y directions. Or north and east. Or, better be careful with my directions there. How about we go east and north? Just to be sort of in line with how we normally draw X and Y. Or horizontal and vertical. So that's how you're going to be seeing it from now on. So, in a nutshell, for a force F, I draw it with a tilde showing it's a vector. It'll have components in the X and Y directions. Who can tell me what to do? Remember, I'm a robot. You just tell my hand what to do. I'm going to start drawing the two components. Where do I start? The origin here, exactly. Now you've got choices actually. There's no one answer. Here, do I go which way? Okay, positive X. So thank you. That's a good answer. You can go positive X to about where? To about there. And then what do I do? and then positive y, go up straight up. So, yes, absolutely. Yeah, actually, really good point. All of these here are going to be, what's the direct? All those are directions. X and Y are two directions. East and north are two directions. Horizontal and vertical are two directions. And what's the relationship between them? Right angled, yep, that's the key thing. We definitely want that. So it's good you raised that. Thanks. We'll put that there, show it. How am I going to label this? What's a nice, easy, convenient labeling system? Well, typically we use it like this. We say that's going to be called F with a little subscript X. And that's F with a little subscript and no prizes for guessing Y.